Good evening. In this video, we will try to see how to draw projection of a line inclined to both the planes. This is the first question in week 4. A line AB of length 70 mm is inclined at 45 degree to HP, 30 degree to VP. Its end A is 20 mm above HP, 25 mm in front of VP. Draw its projections. Okay, so we'll see how to draw that in AutoCAD. So do the unit setting in AutoCAD. Once you open the AutoCAD software, it is already in millimeter only, so no need to change the unit. Make sure the drafting annotation is enabled. Next, set the limits. So the first step with respect to drawing the projection of line inclined to both the planes is we have to draw the reference line XY. So make sure that ortho is on. So draw a line for random length. Okay, so once you draw the reference line, next thing you have to draw two locus. One is NDA is 20 mm above HP, another one is 25 mm in front of VP. So the locus which is present above HP should be drawn above the XY line, and the 25 mm in front of VP distance should be drawn below the XY line. Okay, so that hint I have already told you in the class, you just remember that hint. So just draw a locus 25 mm in front of VP means below the XY line we have to draw that line. So just from here, first point and then 25 mm. Okay, then draw a line passing through that locus, passing through that point. Similarly, draw a line 20 mm above HP, because above XY line, because the NDA is 20 mm above HP. So from the same point you can just draw a line at a distance of 20 mm, for a distance of 20 mm. Then through that point, through this end point, you draw another locus. Okay, so this is the second step after drawing the reference XY line. Okay, next thing is you have to draw a line. Before that, if you want, you can just name the planes as well as name the reference line. So use style ISOPUR format, and then height you can set it as 5, width factor you can give it as 0.5, and then apply. Set current, close. Okay, next type text, specify start point. So we'll specify a start point here. Rotation angle is 0, text is X, and this one is Y, XY reference line. Okay, and this one is VHP, this is VP. Okay, so next what we have to do now, we have to draw the inclined line. So they have mentioned the line length is 70 mm and it is inclined 45 degree to HP and 30 degree to VP. So to remember in short, you 45 degree inclination to HP should be drawn in VP here. So VP is above XY line, so we have to draw that 45 degree inclination line in the VP. So just draw a line at an angle of 45 degree. I'm setting this as first point, randomly I'm selecting first point, then type less than 45 degree, enter, and we know the line length, its distance is 70 mm. So for 70 mm, you draw a line at an angle of 45 degree. Okay. Then through that you draw a locus. Through which you can draw a locus. Okay. Next, similarly, we have to draw the other inclination on HP. Before that, you just extend this point to this locus. This line is projection line. Okay. Next, again draw a line from this point. Okay, and the angle should be, you can see here the line is inclined at an angle of 30 degree to VP. So that 30 degree to VP inclination line should be drawn on HP. In, you have to remember that. So 30 degree inclination we have to draw. So how much it will be now? It will be 90 plus 90, 180, 270 plus 30. So it will be 290. So less than 290. Sorry, control is a TQ. So type less than 290. Okay, and the line length is 70 mm. Okay, so you draw a locus through that end point like we did in the top. Now we have finished drawing the true length. From the true length, we'll try to get the projected length both in top view and front view. So for that, use line command. Extend this endpoint up to this locus. Okay, then with this point as center and this distance as radius, one second, I think I have made a mistake with respect to this inclination. So you can see here it is 70 degree, it should be 30 degree. So I will try to redraw it again. So delete this dimension, delete this line, just draw a line. This locus also I'll delete it to avoid the confusion. Type line from here, type less than 330 because the angle of inclination is 30 degree. So it will be coming as 330 and give the distance as 70. That is the true length. Okay. Then from the corner you draw a locus. Similarly, this will also extend this locus. Okay. Next, what we have to do now? Draw a line from this end point up to this locus. Okay. Then we have to cut an arc using circle command. So with this as center and this distance as radius, draw a circle. Where it cuts this locus, that is this locus, we have to make a point. So just use point command and make a point. Point is not visible, so use P type and increase the size of the point. Okay, now the point is visible. So after marking the point, you can delete that circle. Okay, now we have to draw this line and you have to connect these 2 points. So this is the projected length in top view. You can see that the top view projected length is less than the actual length. Okay, similarly we have to find the front view. For that we have to extend this endpoint up to this locus. Okay, then you have to cut an arc in the top locus also. So first I am typing circle, then with this point as center and this point as radius, this distance from here to this distance as radius, it is cut. We have to draw a circle. Where this circle intersect this locus, you make a point there. So this point I have marked. Then you can delete this circle. Then draw a line by connecting these two points. Okay, so this is the projected length in front view. You can see that that line length is less than the true length. Okay, and you should check whether the answer is correct or not by checking whether these two endpoints of the projected length is along the straight line. You can see here. Let me differentiate the colors of the projected length from true length to avoid the confusion. Okay, then I will show you whether the endpoints are along the same line or not. Okay, so you can see that I have changed the colors of the true length as well as the projected length. Pink color lines is nothing but the true length in the top view and front view. Okay, blue color line is nothing but the projected view in top view and front view. Okay, so let's see the dimensions. Click aligned and check the length of this pink color line, which is the true length. It is 70. You can see here it is 70. Likewise, we can check the dimension of the projected length in front view. You can check the dimension. It will be obviously less than 70. You can see here it is coming around 60.62. Okay. Likewise, in the top view also we can check that. This is the top view length. It is coming around 49.5. Okay. So next we will check the true length also. True length will be obviously 70 mm. You can see it is 70 mm. Okay. And this yellow color line is nothing but used for projection, so you can draw it as a thin line. And as I told you, if you want to check whether the answer you have drawn is correct or not, you have to check whether the endpoints of the top view and front views along the same straight line. You can see here it is along a same straight line. Okay, you can just change the color and I'll show you. I'll just not in the other color, I'll show you. You can see that both the endpoints are along the same straight line. Likewise, this endpoint is along the same straight line. Okay, if they are along the same straight line, then we can say that the answer is correct. Okay, next is giving notation. That is very important. Okay, so we know that the line they have mentioned as capital AB, so we'll use the same notation. Use text. It is asking us to specify first point. This point I will select, and angle of rotation is 0. Text, that is A. Let me change the color. This will be A. This will be B. Okay, this point will be B2. Okay, this B2 is extended up to this point. That point will be B2 dash. Okay, then similarly this is front view. The things which are present above the XY line is front view, so it has to be mentioned with the dash. So this point I will mention as A dash. Okay, this point will be B dash. Okay, and this true length endpoint will be B1 dash. Okay, B1 dash. From B1 dash we are drawing a projection line up to this point, so that point will be B1. Okay, B1. I think all the important points are marked. Okay, so if you can. Okay, so this one you can write it as locus of text. Again, use text command. specify this point, enter 0. This line is nothing but locus of capital B in front view. Okay. Likewise, this line is nothing but locus of capital B in top view. Okay. And then you can give the dimensions for the in-front distance as well as above HP distance. Let's select linear. From here to here it is 20 mm. From here to here it is 25 mm. In-front distance is 25 mm. Okay, so this is the procedures which we have to follow, and you can show the angle of inclination also. You can see here between this line and this line it will be 45 degree. You can see here it is 45 degree. Likewise, between this true length and this locus it will be 30 degree as per the given question. Okay, so if you want to find this inclination also, we can find this line you select, and this locus if you select, it is 55. Likewise, in the bottom you can find out between this line and this line it is 45. Okay, so this is how we have to complete the sum with respect to projection of a line inclined to two planes. Okay, so to do a recap, just first draw the xy line, then mark the in front distance below the xy line, and mark the above HP distance above the xy line, then draw the inclined line for the given true length. The angle, if it is mentioned it is inclined to HP, then draw that angle in VP. Above the xy line it will be VP, below the xy line it will be HP. So if the line is inclined at an angle of 45 degree to VP HP, then we have to draw the inclined line at VP opposite. Okay, just for understanding you can imagine and draw also. Okay, then easy procedure. Just view this video again if you have any doubt in completing the sum. Okay, thank you.